Forever Endeavor large quiz, right? That basically feels like a final because we have so many Forever's Endeavors on our plate. But what are we not doing today? What are we doing tomorrow? All right, taking the quiz. But we had an extra day. We have an extra night in order to fill things out. Guys, there are more coding and handwriting forms at the front. If you guys lost yours and you need another one, I have some extras copied off. We'll do like stamp sheets and tutoring forms and all that jazz tomorrow. Tomorrow, if you guys come to zero period and just enjoy coffee and donuts and hanging out and catching up, that'd be cool. Or you could be quizzing AB kids or BC kids on their Forever's Endeavors. Don't quiz AB kids on integrals. That would be sad. Although they heard the word integration today. They are also doing their first and second derivative graph match. That could be fun for you guys to help with if you wanted to. But we'll do stamp sheets and tutoring forms and all that jazz tomorrow. Let's not stress about it today. But you do have your Forever Endeavor quiz tomorrow. Any questions on the assignment? I know it's hopefully just good old-fashioned. You know what you're doing by this point, but okay. So we know what's going on with that. What do you have in front of you, though? Ooh, we have a full-length practice exam? Barron's? Who's Barron's? Anybody know who Barron's is? It's one of those AP prep books. Here's a reminder. Are there AP prep books out there? Yeah. Could you get one? Sure. Do you need to? I don't know. Maybe. Maybe, right? However, I want to remind you of something else today, but we'll do that in just a second. There are also a lot of resources online that you could always supplement my instruction with also. But what do you notice about an announcement that is coming? Oh, just kidding. It's not super obvious. An announcement that's coming is going to have attached not just the exam, but also, ooh, what are these? The answers. Question. How many questions are on this BC practice exam?
45.
Ooh, more answers. 45. 45. 45 is not a number that we know in AP exams. Don't we know like 28 and 17? Oh, just kidding, that changed. Don't we know like 25 and, no, 30 and 15? Isn't that what it is now?
That's 45.
Oh, they add up to be 45. So is this a full-length practice exam? Yes. But is it like strangely numbered and randomly starts like numbering at 75? No. So find for me where the non-calculator and the calculator sections are separate. Lainey, what number?
29.
29 says you're allowed to start using your calculator. Okay, is this an older practice exam? So it's the old 28-17 instead of the 30-15? Yes, but either way, is it non-calculator practice and calculator practice? Yes. Now, hold on. At what point are we in our BC class? A little over halfway through. So you're going to be able to do this entire thing. Oh. So what I want you to do right now in your old groups that are, well, soon going to be your old groups, but for right now they're your current groups. In your old groups, kind of like a last hurrah, can you guys quickly maybe give everybody a page to go through where you take the first 10, I'll take the second 10, you take the third 10. Can you guys try to find ones that we don't know how to do yet so you can cross them out and not even worry about them when you get there? Let's narrow this down. Ready, set, what don't you know? Go.
Halo series number 5.
Woo! He's giving it away. We'll powwow in a second and see what you found and see any other ones you can cross out. Cross out as many as possible.
I saw Simon's one. I said that. How fast? Do we know 3/4 circles?
What number 9?
That's 24.
Have we done 9?
Yeah, that's
Do we know that one?
Describing
the graph. We just have to find out the I don't think we know 27.
I think so. I think it's I think we've done it before.
It asks for outside the card.
No, it seems like people are doing it for me. So that's a
Oh, Ryan.
I didn't think about that.
Oh, that's
We've done all
funny.
Oh, 31. 'Cause I think we did like parametric forward. I don't think we've done that. Right?
Intentions, not resolutions.
I don't know. Maybe 39. I don't think
Yeah. Oh, like, we haven't learned it yet.
Oh, I didn't know.
Did we do 31 to
31? I think 39.
It's like,
We learned it last
no,
year.
because we're going
Oh
back
yeah,
to
we don't know power series.
Power series. Oh, that's exciting. But yeah, no, you don't.
Do we know
I feel like we skipped too
cardioid?
much. I feel like we really skipped enough.
Cardioid is a no. Cardioid's a fat no. That's polar.
Okay, so 27 crossed out.
For long, it's
Okay, we didn't do
What about 3/4 circles? Or are we still?
We don't know what a
Like 3/4 circles.
Isn't that the plus? Or is that the lean?
If it's defined in x's and y's, if it's defined in betas, maybe not.
What time?
Actually, cardioid.
That's good.
Yeah.
23? Yeah, I think it's really
I'm not
crossed out.
Do you remember which one was what?
It's the lean source.
Parametric and polar, you can just ignore for right now. Anything parametric and polar. Even though you might have seen, you haven't seen the calculus to it. Don't worry about parametric or polar.
We know acceleration vector stuff, right?
Yeah.
Cardioid is what?
Vectors are kind of still going to be new, but
It's asking for the,
I think.
what is that?
I think the SCP.
What?
Yep.
I'm never gonna think about
we're going to narrow it down and make sure you guys are good.
Really? That was like,
I think you can, but like you can't submit it.
You can do it for fun.
Yeah, you can do it. I think there's a guy on Reddit who just does it for fun.
no, I could see the
Oh really? I thought he was just some random kid.
like, see this guy, since I was a kid.
No, I think he's just
Yeah.
some nerd.
I think he does like SCP prep, so you have to get
You guys are a little bit rough.
Nuh-uh.
That's an occupation.
He's like
was your
in a
previous
lot of
teacher?
classes.
Good.
But he
Oh yeah.
In some ways it was nice just to like totally detach. In some ways I have a lot of work to do. In some ways it made me think a lot about life, which is sometimes good and sometimes hard. So, two sides.
I've decided when
How
I
about you?
graduate from college, I'm going to be at my peak IQ in life, so I'm going to go take an IQ
You'll come talk to me about it.
after college.
That makes sense.
Yeah, because then I'll be educated.
No, that's just for you, though.
This, the
I'll
I'm
be like
accepted
25,
into
I'll
the
be
college,
like
I got out.
Yeah, exactly. So why not go?
Yeah, that's
Not important.
Yeah, but aren't you curious? Like,
Alright, do you guys have them obviously marked? That way we can figure it out?
like I also want to know,
Okay.
like, I want to do a 23, just like let's do 3. That's good. You can only pick one.
Alright, I'm going ahead and posting this on your Google Classroom. It's Barron's practice exam. It is the actual exam itself, which you already have. So you already have that one. Here's just the strict multiple choice answers. You can grade it once you try it. And then there are two different versions of solutions. One teacher's handwritten form, but then also typed out form. But let's figure out what you do or don't know how to do. Sound good? Okay, so what do you think on the first page? Well, you guys realize you have like 2 pages per side, right?
Yeah.
So on the first page, which is like what, 1 through 8? Anything you can't do?
5.
Oh, you can do this one, which is the stepping function? Yeah, you should be able to see that. But yeah, number 5 is a no, but what else should have been a no way before number 5? Yeah, number 3 is a no. Oh, but it has a sigma. I know, but whenever you see the word diverges for right now, it's a no. For right now. And in a semester, it better be a yes. But for right now, it's a no. Parting the sea. Moses, parting the sea. Remember that. Okay, number 5 is a no. Number 3 is a no. Anything else? Number 8 is a no. Yeah, that's okay. Number 8 is a no. Series. says when a series is used to approximate. Yeah, we'll just say no. Okay, but besides that, I'm pretty sure it's a yes, right? Okay, next page, or next side, sorry, same next section. 9 through 16, what do you guys think? Yeah, I think you should be good on all of it. We agree?
Yeah.
Okay, cool. Number next one. 17 through 22. Anything is a no? Sorry, 23?
18.
18, yeah, that's okay. 18, say no, because it's parametrically defined. Arc length, is it a thing we've done? Yes, but only with one function, only in terms of one function, not parametrically defined. So yeah, 18's a no. Anything else? Oh, what's number 22? It's BC, but we can do it.
Oh, what was the...
Ultraviolet voodoo, aka integration by Adam. And then what about that guy? Related rates, nice. All right, next section.
27.
20. Yeah, 27's no because it's defined how? Not parametrically, but polar. Yeah, it's polar. It's not parametric, but it's polar. I'm not sure he would make that an adverb, so we'll just say no. But yeah, 27's a no. I think the rest is yes. True?
Yeah.
Okay, now, according to this old exam, at this point we've switched to calculator. New exam, we know we have 2 more and then calculator, but that's okay. The topics are pretty similar. Now what?
31.
Yeah, I think you could do 29. Technically, it's still kind of parametrically defined, but in a way you should be able to do. But yeah, 31 is a no because of the polar. 31 is a no. I think the rest is good, yeah? Now, can you guys circle number 34? Wherever they put things like y equals k or x equals k, it's always interesting. It's not impossible, it's just an interesting one. Because it doesn't necessarily, well, you have to figure out where the k is in order for, anyway, it's interesting. Just circle it, interesting. Try it, just, those are always a little tricky. How about the next one?
39.
And to be honest, can we cross out 37 too? Because I know that you've seen acceleration, but remember how we're not dealing with parametrically defined motion yet? 2-dimensional motion? Not yet. That's actually the last thing we cover this semester. This is an acceleration vector, which means it's defined in terms of an x of t and a y of t. It's a parametrically defined acceleration. Anyway, super interesting, but cross out 37. I don't want you to even worry about it. But you also said 39. Yeah, no. Converges. Anything else? I think we're good, yeah? Okay, next set. 43 to whatever's. Anything there? Ooh, can you circle number 45? And I want you to think Gophers. Where did Gophers show up last semester? The road, was it groundhogs or was it Gophers?
Some sort of groundhog.
It was a furry. It was a furry, something near roads that they would die and farther. Prairie
It
dogs.
was squirrels, I think.
Squirrels. I don't know.
Squirrels?
He visualized squirrels whenever the rodent-ish creature came up. So why am I bringing up gophers or groundhogs or prairie dogs or squirrels?
One problem.
That one problem where we were talking about the density. Oh, fragments per square meter. We're talking about density and how much there is, the accumulation. Anyway, circle bomb fragments. No World War III nerds. Okay. What do you guys see? In the announcement, I'm not making it an assignment. I don't want you to attach pictures on Google Classroom. It's not that kind of thing.
Monday. Oh no, that's true. Oh no.
Do Monday. I know. Do Monday, right? So do Monday after the weekend. Attempt to grade it and correct it as much as possible, aka come with the questions that you don't understand. Sound good? But what are you doing to all the ones we just crossed out? Ignoring completely and entirely. Sound good? Yeah. Cool. So this is kind of like on your back radar. This is on like you're carrying around and have it with you. But I also put the copy of it. That way if you guys ever get caught without it, you can go ahead and just go in your Google Classroom and access it. However, Abby, what were you bringing up that's due Thursday, which is much before Monday? Trigonometric something or other. Let's go look at it. It's right down here. Trigonometric. Maybe you remember last semester I mentioned that there were like types of integrals where you have to use triangles to solve them because there's no other way. We're going to go ahead and do an aside. Now what I didn't realize until just now is when this popped up for you guys this morning, I actually didn't have the handouts attached to it. So I'm attaching it to it now, but as I attach it to it, I actually do want you guys to grab your notes out because some of you might be going on in calculus, and if you go on in calculus, your professors might refer to trig sub, and if they refer to trig sub, I want you to have a place in your notes where you've done it. So I'm going to show you the worksheet. I didn't make copies of it. I'm not handing it out because the worksheet, I want you to do it in your homework spirals as an end of chapter 8 homework. So you're going to be able to see the worksheet kind of like a practice test, or sorry, a test review. You're going to be able to see it in Google Classroom. But you don't need the printed off form. You can just do it as a normal homework in your homework spiral. So you guys are getting your notes out. You can just put it at the end of chapter 8. I have it at the beginning of chapter 9 just because it's starting off our second semester, but it's technically more like at the end of chapter 8 in your, yeah, here we go, chapter 8. Because it's technically another way of solving integrals that you haven't seen before, at least not much. But let me open up the worksheet just to show you what I mean. What this homework assignment is, I think it says the evens of the practice problems. So on this worksheet, there are sample problems, and we'll do some of those sample problems. Oh, please. Come on, computer. He's been so mad, like, all day. Okay. There are these sample problems. We'll do some of them in class. However, there are also practice problems. So the homework, check it, eyes up here. When you open this in Google Classroom, you are skipping down to the second section, and you're doing just the evens. So 2 and 4 and 6 and 8 and 10 and 12 for Thursday. Does that make sense? Mm-hmm. Now what's really nice, check it, is the solutions to all the sample problems and the solutions to all the practice problems are here. And worked out solutions to the sample, not homework, sample problems are down here. Okay? Which means if you get stuck on a homework problem, if you get stuck on a practice problem, what could you do up here? For instance, number 8 is probably going to be kind of brutal. But for number 8, what's up here in the sample problems? A number 6 that looks really similar in that it's a fraction, in that there are x squareds on the top and the bottom, and in that I bet they're fairly similar in how they're solved. And what's down below for number 6? A full worked out solution. Does that kind of make sense? Okay. So you do not have all of your practice problems fully worked out in here, but you do have all the sample problems fully worked out. So if you are working on the evens down here and you get stuck, you can go up and try to find a similar problem, work it through, and then try to apply. To that end, let me go ahead and pause for a second. Let me get you guys writing down the first page of notes. Oops, that's not you guys. Sorry. Trig sub aside. Why is it an aside? Because there's absolutely no integral on the AP exam this year or any year that requires this process. But why am I still covering it? Any college professor calculus class would have taught trig sub. Does that make sense? Okay, ready, set, frozen screen. Let me get this announcement going into your Google Classroom and all nice and posted. Save. And where are you doing this homework? Do you have to print it out or anything crazy like that? Nah, you're just doing it where? Yeah, homework spiral. Thanks, kid. Is there a 0 period tomorrow? Yes. Have you guys heard me say that this is useful, aka important for integration? And do you see it in your notes? Trig substitution. It's useful for integration. It's helpful for understanding the derivatives of inverse trig and for understanding the integrals for inverse trig. But it makes some impossible integrals possible. Can I put up on the screen for you guys a formerly, before this process, before this entire procedure, a formerly impossible to solve without geometry. A formerly impossible to solve without geometry integral problem. Is that cool? Now, hold on. Just by me saying that, could this problem I'm about to show you, could it have shown up on an AP exam? From what I just said. A formerly impossible without geometry integral. Could it have been on an AP exam? Yes. Why? But it's impossible. It's formally impossible. We couldn't have done it. But what did I say?
Geometry.
About geometry. This could have been on an AB exam. You should be able to do it an AB way. Let's not do it that way. Let's do it this way. Because I heard something somebody said. I'm curious. Ready, set, how would you solve? Formerly impossible without geometry. So right away it was possible. You had to use geometry. You cannot use your algebraic techniques to integrate this or to even find the antiderivative. How do we use geometry to solve?
You know it's like a circle, or like a semicircle.
Ooh, semicircle. How? It's a basic graph, right? X squared plus y squared is r squared, so r squared minus x squared square rooted is a semicircle. So then, Kevin, how do we use that then? In this one.
So we just do 1/4 pi.
Ah, y 1/4. Someone asked about a 3/4 circle. It's very similar to how we would do a quarter circle. Just think geometrically. So instead of 1/2 pi r squared, the half circle, it's 1/4. It's a quarter circle, and what's in here? So what's the final answer? Dun, 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 dun. That's easy. Okay, so what's the antiderivative? Fundamental theorem of calculus. Because it's a quarter circle because the bounds are just 0 to 3. So in this one, my radius was 3, so he's a 3, and he's a -3, and he's a +3, so 0 to 3 is just that quarter piece. Yusuf, 9 minus x squared. Fails, because you're thinking ahead, because you can do mental math on integrals now, right? What's u prime, or du? And it's not there. There's no x in front. A squared minus u squared. It's an inverse. No, it's not, because all inverse trig has what on top? 1 over the square root of a squared minus u squared. Well, it's not inverse trig. Nope, because there's not two pieces. There's only one. Nothing. No algebraic way to solve. But I said formerly impossible, because what do you see right here? A square root of an a squared minus a u squared without a 1 over, and somehow we're supposed to deal with it. Now, do we have an AP exam coming? Yes. Is it here yet? No. Have we talked about baryons and other AP prep books and how those could be useful along your journey this year and getting ready for the BC exam? Yes. But did I also allude to how there are online people that are also very helpful? Yes. Who am I looking at? Whose channel? Whose video? Do we know about Khan Academy? Yes. Do we know about Patrick JMT? We should. Do you know about the organic chemistry tutor? Maybe. He does calculus too. Now we're not going to listen to this entire thing because, to be honest, it's 25-ish minutes and he sometimes talks a little slow, but it's good because he has a lot of stuff going on that he's explaining along the way. He doesn't have as many colors as Khan. He doesn't have cool whiteboards like Patrick, but he does have good content. Can we just listen to his introduction to trig substitution? Because he might be useful because he goes over not only AB topics but also BC topics. And do you guys remember that this semester is mostly entirely new to you? Uh-oh. Some of you have been kind of depending on the whole old thing, review thing. So it's going to be a little bit rough this semester if you don't remember that you can't stop working. Second semester, senior year in Calculus BC. I'm not saying you can't stop working anywhere. I'm just saying don't stop working here. This guy could be helpful. David Rosso, do you like him?
Yes.
Yeah, you do. Ready, set, go.
In this video, we're going to talk about how to find the indefinite integral using trigonometric substitution. Now, there's three forms that you need to be familiar with. The first one is the square root of a squared minus x squared. The second one we'll look for is a squared plus x squared inside a square root function. And the last one is the square root of x squared minus a squared. Now for the first one, you need to substitute x with a sine beta, where a is a constant. And the reason for that is because 1 minus sine squared is cosine squared. For the second one, replace x with a tangent theta. And the reason for that is 1 plus tan squared is secant squared. And for the last one, replace x with a secant theta. Because 1 secant squared minus 1 is tangent squared. Now these are the three forms that you need to look out for when using trigonometric substitution. So let's work on an example problem. Let's say if we have the square root of 4 minus x squared divided by x squared. How can we integrate this function? So notice that we have the form square root a squared minus x squared. So we can clearly see that a squared is 4, which means that a is equal to the square root of 4 is 2. Therefore, we need to replace x with a sine beta. In this case, x has to be 2 sine beta. So dx is going to be the derivative of 2 sine beta. So that's 2 cosine beta d theta. And so now we're going to have the integral of 4 minus, let's replace x with 2 sine beta. So this is going to be 2 sine theta squared, and then divided by x squared, which is also 2 sine theta squared.
Just substitution, right,
Now let's
guys?
replace dx with 2 cosine theta d theta. We can get rid of this for now. So now we got to do some math. So let's perform some algebra techniques to simplify this expression. 2 squared is 4. So 2 sine squared is going to be 4 sine squared theta. And on the bottom, we're also going to have 4 sine squared theta. Now, what do you think we need to do at this point?
Don't kill a puppy.
At this point, we need to take out 4 inside the square root. So we can get 1 minus sine squared. So we're going to have the square root of 4 times 1 minus sine squared theta. Now, something else that we can do is that we can cancel 2. 2 over 4 reduces to 1 over 2. So there's going to be 2 left over on the bottom. We still have cosine theta d theta. Now we can take the square root of
Can you guys keep up? You ready?
the square root of 4 is 2. And then we can replace one sine squared with cosine squared. So the cosine squared part is still inside the square root of 7. So now in this part, we can cancel 2. 2 divided by 2 is 1. And the square root of cosine squared is cosine theta. So we have...
Okay, now wait, pause. Well, remember there was a sign up here and he reduced it. There was a sign square, but then there was a sign here, and so he reduced that sign away. But what's the dilemma about what he just said? Some of you should have caught it. Picked up on or been wondering about. He just said the square root of cosine squared is cosine. Oh, is it cosine?
Absolute.
The absolute value. Oh, sick. So why didn't he put the absolute value? In trig sub, at least for the next couple of days and when we're doing it, basically I looked up a lot of different places trying to find an adequate explanation, because in other places in calculus, do we have to be careful that a square root of a squared is an absolute value? Yes, we do. The struggle is with trig sub, we basically ignore it, and the reason, the best one that I could find, the explanation is, as long as we are very careful for values of cosine of theta, and eventually, it didn't start in thetas, it didn't start with trig, we substituted in trig to be able to deal with the function in terms of x differently, and to be able to manipulate in ways that we couldn't have really helped ourselves in terms of x. We can do it when it's in terms of trig because of like trig identities and things like that, like Pythagoreans, that'll help in rewriting and considering what else is going on from a different perspective or a different view. Long story short, for very careful values of cosine, and once again being careful with the representative, or the final, I should say, the final antiderivative in terms of x, we're allowed to ignore that absolute value property, which is hard because we're not going to actually be considering that at all. We're not going to actually be thinking about that or doing that be very careful step. Instead, we're just going to be playing with an integral, getting a final antiderivative, and not really worrying about domain restrictions. So some of you wouldn't have even thought about it, and you would have just gone to cosine, and that's dangerous. Some of you guys would have thought about it and had an absolute value and been like, now what, and be stuck. So we're allowed to, for trig substitution, because of this basic, people way smarter than us who are saying, hey, it's okay, just go ahead, proceed forward, and then we'll think about it later. We're going to proceed forward and not think about it later. And that's just all there is to it. You're going to see this with things like square root of secant squareds and square root of tangent squareds. We're going to ignore the absolute value. Long story short, it's okay, it's acceptable, and it'll work out just fine. For our purposes, at least. Oh, he didn't simplify? I thought there was a sign. Good job, guys. Maybe what's cosine squared over sine squared? Cotangent squared. Is cotangent squared over antiderivative? He's doing it that way? He can. He's going to go with that. Maybe cosecant squared minus 1. Isn't cosecant squared minus 1 cotangent squared? Hey, don't judge, he's smart. He's doing it a different way.
So let's move this.
There's an ad. We're so close.
Let's see what's inside. I really like the build.
Don't worry about it. Can you keep up? Oh, he's doing it this way? Why is he doing it this way? Is there an integral of cotangent squared? Could we have written cotangent squared? Yes. Is there an integral? There's an integral of cotangent. It's like the weird ln of sine plus c, but what about cotangent squared? Derivative of cosecant is cosecant cotangent with a negative. Derivative of cotangent is cosecant squared. Is there an integral of cotangent squared? No. So we could have gone cotangent squared, but we would have had to have made it cosecant squared minus 1 to make it integrable? Integrable? I never figured out how to say that word. Anyway, to make it able to be integrated. So even though you guys are like, oh, he's doing it the hard way, well, actually, he's just trying to get to this guy who we can integrate.
Now, this is the answer to the integral, but not with the appropriate terms, because it's not with x variable, and now we have to change theta back into x variable. So how do we do that? Now recall we said that x is equal to 2 sine beta. So if you divide by sine by 2, sine beta is x over 2. So we can make a right triangle. Now you need to remember the principles of SOHCAHTOA. The SOHCAHTOA part of SOHCAHTOA tells us that sine theta is equal to the opposite side divided by the adjacent side. So let's take the angle theta here. So opposite to theta is x on top, divided by the hypotenuse, the hypotenuse is 2. Now we gotta find this inside. So in any right triangle, you can use that diagram here. C squared is equal to a squared plus b squared. C is the hypotenuse is 2. You can say theta is x, and b is the inside of the theta. So 2 squared is 4. And if you subtract both sides of x squared, you're going to have 4 minus x squared is equal to b squared. So the side b is going to be 4, the square root of 4 minus x squared. So we have that here.
Technically, there's an absolute value, plus or minus, depending on the quadrant. It continues to get tricky,
Now,
right?
theta is x